Good evening, everyone. The world is full of diamonds and gems, and we are having some of them here today to build this event. With this note, I would like to give my heartiest welcome to all. It gives me immense pleasure to extend to you a very warm welcome on behalf of Sri Venkateshwara College of Engineering, Tirupati. Now, the power of prayer is still the greatest ever known in the endless eternal universe. Now, I would like to request A. Hemika, second year Triply department, to sing a prayer song for a beautiful starting.
Good afternoon. Mahaganapatim manasa smarami Mahaganapatim manasa smarami Mahaganapatim manasa smarami Mahaganapatim manasa स्मरामि वसिष्ठवामदेवादिवन्दितं महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दितं महागणपतिं महादेवसुतं गुरुगुहनुतं महादेवसुतं गुरुगुहनुतं मारकोटिप्रकाशं शान्तम्. Thank you.
A great starting with Lord Ganesh. Now, I consider it a great honor to welcome our college principal, Dr. Sudhakar Reddy sir, onto the line and speak a few words on behalf of this event. Welcome, sir.
Good evening. Hi. Good evening to everyone. My hearty congratulations to the team of Triply department headed by Dr. K. Sudhir and many other active faculty members of Triply department. Very good evening to one and all. I am very happy to know that Department of Triply is conducting a 5-day national level e-workshop on Matlab and its applications in electrical engineering for students in association with ISTE student chapter. And my sincere thanks to today's resource person, Dr. Ramji Tiwari Garu, Assistant Professor, Academic in Charge for Triply Department, Bharat Institute of Engineering and Technology, Hyderabad. And I came to know that many participants are from outside Andhra Pradesh, and one participant from Oman country. It's really it is a great achievement by the Triply department, and Department of Triply faculty. You have lots of expectations by the faculty, by the participants. So please make this event or make this workshop a grand success. So nowadays MATLAB is required for any electrical engineering student or faculty, especially because it can be used to enhance and accelerate some of the processes in different fields, control systems and magnetic field measurements and simulation and explanation, data analysis and modeling. So in various fields, this MATLAB is necessary nowadays. Without learning MATLAB, we can say we cannot complete electrical engineering subjects. So this is a great initiative taken by the Triply department. I hope all the participants will definitely learn by hands-on experience of MATLAB applications through the resource persons. So definitely, I hope you can gain knowledge by attending this workshop. Thank you so much for providing me this wonderful opportunity.
Thank you, sir. Thank you so much for your valuable words.
Thank you.
Now, the next resource person to honor us with his presence is Dr. Ramji Tiwari. He did his full-time PhD in VIT University in 2019, and he also did his ME and BE in Anna University in 2014 and 2012 years. He has a very good experience in teaching and started his career as a quality supervisor in Jai Bajrang Pump Company, Coimbatore in 2018, and also did as assistant professor in Bharat Institute of Engineering and Technology in 2018, Hyderabad. Next, he also did research in PhD level on modeling and analysis of efficient control strategies for wind energy conservation system. Sir is also a professional memberships in social activities like ISTE and also IEEE. And he is also having more than 30 plus publications in journal and as well as in conference publications. He has skilled with the basics of C, C++, MATLAB, PLECs and also Origin. He also certified to be advanced by University of Cambridge in English speaking test at the Kathir College of Engineering. He is active member of National Service Scheme and also now currently holding a position of training in charge in the department level since 24th July 2018. The key role is to give a sufficient training to the students and make them industry ready in various core domains, and also acted as an academic in charge for department for one academic year from 2018 to 19. Currently, he has appointed as an lab in charge for simulation lab. Welcome you, sir, and also wishing you a day filled with happiness and a year filled with joy. Sending you smiles and every moment of your special day. Have a wonderful time, sir, and also many more happy returns of the day from EEE department and also from Sri Venkateshwara College of Engineering, Tirupati. Now I requested Dr. Ramji Tiwari, sir, to take up the session.
Thanks for the wonderful welcome. I'm just pleased with that welcome. Moreover, I just thanks Dr. K. Kumar for organizing this opportunity for your students. Actually, I can see here the maximum participants are a student. Since I was a training in charge, and I know what students need is once they complete the 4 years of your EEE course. Moreover, I thank the principal of SPC and the HOD of SPC for giving us such a platform for the faculty to develop themselves and to develop their students. Okay. So, let's start with your presentation.
Sir, excuse me, sir.
Yeah.
So here are some instructions for the participants and they have to follow.
Okay.
Must to follow. Sorry for interruption, sir.
Okay.
Okay. Here, first of all the participants are requested to mute your microphones and turn off your camera. And second thing, all the participants are requested to pin the resource person screen. All the participants are also suggested to listen the session and note down key points, and we will share the video presentation link, and participants can practice the MATLAB later by following the shared videos. And if any queries, post your queries in chat box and all the queries will be answered by the resource person during the session only. Thank you. You can continue, sir. Thank you, sir.
Thank you. I guess you can mute your microphones. Yeah, thank you. Thank you, Ramji. I was said that the maximum participants here were from second years and third years. So MATLAB is something new for you. So the first day of your workshop, what sir has emphasized me to do is basics of the MATLAB and what is the use of MATLAB and Simulink platform. In your MATLAB. So my entire presentation will be on basics of the MATLAB. So what is MATLAB actually? Why do we need MATLAB? Everyone says that MATLAB, if you learn MATLAB, you can easily get placed or something like that. Why do we MATLAB? What is MATLAB? Actually, just see, it's a small platform where you can test any of your system, okay, in prior to your implementation. Suppose I'm just designing a small circuit. I want to test the circuit. Instead of directly for implementation, I want to test the circuit. Then I can use MATLAB software for that. So that's a major thing why we students use. Other thing is that basic operations like your mathematical, it's just like a calculations, like a calculator. You can use as a calculator for basic calculations. Apart from that, to like schematically view your any circuits which you are going to perform in future for your like your projects. Also, if you're going to for your projects, then you'll be having something like your converters or inverters, something like that. So directly going for the buying your equipment, you can just test your system first in the MATLAB, check whether everything's fine or not, everything is in the optimal range or not, and then you can go for your procurement of your devices. Okay. So like what do we have in the MATLAB? The first one, what we have is your basic operations that comes under your command window. I'll be explaining about that. Next come your M files. M files are nothing but your coding, similar to your C coding, only a few changes in that. And third comes your Simulink platform. So there are three major platforms which we're going to talk about today. Okay. So that's the viewer. The first one is your MATLAB, and that will be having all your basic command windows, your M files, and then comes your Simulink. So what is MATLAB? What is abbreviation of MATLAB? Is nothing but a matrix laboratory. Initially, that was developed by an lecturer only in the year 1970 to help students to learn basics of your algebra. Okay. Then in the year 1984, MathWorks, which owns the rights of MATLAB right now currently, he has developed that and is marketed with the name of MATLAB with certain versions. Now currently a version 2020 also came. Okay. But we have furthermore every year, based on the demand, based on what is requirement, each year there will be developing, the backward team will be developing a certain new contents in that. And third one comes like what is generally we as engineer, we need to solve our small basic problems. So we are going to use MATLAB for that. Other than MATLAB, what softwares we can use? We can use Piecewise, you can use Xilinx. We have more softwares. But why you use MATLAB is that first one, it's very easy for implementation. If you just see, MATLAB is quite easy than your Piecewise and everything like that. And moreover, and it is have very high connect packages. Like if you want to connect your MATLAB to your hardware, like using some Piecewise or something like that, it will be very, very easy for you rather than compared to other softwares. So that makes this one very much easy to implement system. And third one is available in all your Windows, your Mac, you can use in anything, whatever you have. And moreover, you'll be having many suitable toolbox based on your problems. Whatever problems you'll be having certain toolbox for that. Then Simulink. The next comes to Simulink. Simulink is also a platform of a MATLAB, okay, or something differently. Till now, what you're doing, your till M files, you'll be using some code like structures like what you have in your C, C++, something like that, and going to solve your problems. But in Simulink, what you'll be doing, you'll be going with the schematic diagrams. Say your circuits, your Rlc circuits, your converters. So that particular thing, a graphical way of your circuits, you're going to test here in your Simulink platforms. Okay, so it's just like drag and drop only. You will be having all the toolboxes. You're going to drag that to your Simulink file, and then you're going to connecting that, and just you'll go to change your parameters, and after that you're going to run and you're going to get your results. It's quite simple. So how to start? So basically, if you want to start your MATLAB, so if you just see Windows 7 and earlier versions, you'll be having something start, programs, all programs, and then you'll be going for the MATLAB. If you're using Windows 8 and above, so you can, I guess you can see my screen will be having start here. You click start. So you'll be having a program here. You can actually drag it to M, and you'll be having a MATLAB. If you click this one, you'll be getting something like this. The first page will be something like this. Okay. So this will be the initial page of your MATLAB. When you open your MATLAB, we'll be having the first page of your MATLAB will be something like this. We'll be having a command window. You'll be having a workspace. When you are first time for MATLAB, this current folder will be empty. You won't be having anything. It's just a MATLAB folder in your C drive. Okay. Then next, what happens? So this is what I was saying you. Once you open a MATLAB, I've already opened that. So it's here. And you open, you'll be having your current folder. You'll be having your workspace. You'll be having your command window. So command window is nothing but you're going to like if you're going for a basic calculations, you're going to assign some values. Let's say I'm going to do for some multiplication. I'm going to assign some value for A, and I'm going to assign some value for B, any variable, and I'm going to do a multiplication of A into B. So I'll be getting that thing. The same thing you can see, the values which I'm performing here in the command window can be seen in your workspace too. So that's why the workspace is used for. Okay. In whatever you're doing, command window, whatever answers we're getting, like I've assigned a value for A, I've assigned a value for B. Now I have done a calculation for A into B, so that everything you can see in your workspace too. Okay. Whenever you have done with your once you are done with the calculations, kindly when you start with the second one, you have to use CLC, like what you use in your C programming, and you have to clear all, so that once you do CLC, the command window is clear. Once you do clear all, your workspace will be cleaned completely, because you should not keep any old data here, because when you perform a new task, and if you're using the same variable, let's say I'm going to use A again and again, so that will be impacting your results. For that reason, always when you start a new operations, you have to go with your CLC and a clear all. So now next, something like why now I won't want to go for again the basics of your basic multiplications or divisions. I'm going to tell much more advanced what we're going to do with matrices, the basic matrices, what we see in your college in first year or in schools. You'll be having like your matrices. Okay. So if you want to give a column vector, you're going to use a code something like this. You'll be using a semicolon between your variables, something like this. Okay. I'm going to open the bracket. I'm going to use semicolon for generating a column vector, and if I enter that, you get your column matrix here. Now, what if I'm going to do a row matrix? I can just give like D equal to, I can open, I can give space. To use space for that, and I have to enter. So you get a row matrix. This is how you generate your matrix. So this is just one by one. Now, what if I want to go for your 3 by 3 thing? If I go with C, 2, 3, a semicolon. So one row is completed. Now second row, 4, 5, 6. Again, a third row now, semicolon. You have to segregate your columns using semicolons. 7, 8, 9. This is how your 3 by 3 matrix has been generated. So it's all very, very basic. I will be sharing you the PPT to your organizer, so you can have a clear look on that. So in the PPT, I'll be having like all how to use the basic matrices and everything into that. Your column vector, your row vectors, and your 3 by 3 matrix. Now you have a matrix, but how to perform a certain task with that? Suppose now I want to perform. Now I have 2 matrices. I'll just generate one more matrix. I have 2 matrices. Now our basic matrix operation, what we do, we either do a addition of a matrix like C plus B. So this is your basic matrix additions. It's quite easy actually. Once you do in your manually, it takes lots of time. Oh, okay, addition is okay, subtraction is okay. What if you want to find square of something, or you have to do for multiplications? Something at that time it takes a lot of time. So here it's like it's very, very easy. It's very quick. Now I'll just go with some multiplication. You see, it's very quick. So you can do a matrix multiplication, divisions, and we have something called element to element multiplications. Have you heard of name something called element to element? basic matrix multiplication will be like row into columns, but element to element is that, like we say your A11 into your B11, your A12 into B12. They're using something like that. At that time, you have to use something called dot matrix there. Like say G equal to, if I want to do an element to element, I should use C, a dot, and then your B. So to have an element to element. So what's the difference of this one? You can see the answers. If you just go with C into D, 17, 24, 24, it's like row into column, your usual way. And when you go for the element to element, what happens? You can see your C and D here. Your 1 into 1 is 1, 2 into 3 is 6, 3 into 4 is 12, something like that. 1, 6, 12. I go with the PPT, it will be more clear for you. Here. We have two matrices. If you want to do element to element, then you have to use a dot here. It's like 1 into 1, 2 into 1, 3 into 1, and 4 into 2. Same row, same column. It will multiply and give you an answer. What if I want to find a square? Because again, square finding is very much difficult in your manually. So at that time, you have to use your exclamatory mark. I will just show you like that. Suppose I just give some variable name P, which will find my C square of that. Yeah, one more thing I have to say here. It's very case sensitive actually. And if you're using a small c and if you give a capital C, issue may happen. So you have to give always a same variable what you're giving. Whether it's a small, you're using a capital alphabets, you have to give the same variable. It's very case sensitive. So for using your square, you have to use this symbol. So this is the basic operations what we do in your command windows. Command window is something like a calculator. Your basic operations you're going to do here. Okay. But next comes your M file. This is where actual work starts. Your actual MATLAB starts from your M file. So M file, as I said, in command prompt, you're going to use very like simple problems, simple operations, and everything like that. But when you come for the M file, you're going to use a complex problems, or the problems which can be, you're going to use it again and again. You have written a code and you want to use this code again and again. At that time, you have to go for your M files. Again, M files are classified into two types. The first one is your script. The second one is your function. Now, something about your script. Script is something same like your C programming. You're going to program something. You can get your results. That's it. But whereas your function comes, function term, the function files, actually it's embedded in your Simulink. You will be having a code. You're going to embed it in your Simulink, where your input variables are going to change according to your Simulink variables. Once you emphasize that thing in your Simulink block, suppose you're going to change your, you have certain problems where your voltage keep on changing, and you, based on changing of your voltage, you want a specified output based on your voltage. At that time, you're going to use your function block. Okay, so function block is generally embedded with your Simulink folder. But whereas your script is nothing but a simple a page will open. You can just give all your data, what you want to give. You can assign your data there. You can run your data, and you can save it for your future use also. Just show an example. So, how to open an M file? First, I'll tell you about it. You just see there'll be a new script. Okay, if you give a new script, then you'll be having a editor box will be opening here, an editor page. So this is where you're going to type all your codes, like you are going to type for your C, C++. The same thing you're going to type it here. Okay. So already I have a small code or an example. I'll just show you that. I have a code for your simple Rlc circuit to determine your current. I'm going to just copy paste the same thing. So I'll just copy paste the same thing. So you can see in your code what happens. You're going to predefine your your capacitance value, your inductance value, resistance value, the voltage, everything you're going to predefine, and you're going to use your W is nothing but your angular frequency. You're giving us like one dot of this 50,000. You're going to give your formulas. Your XC, you have, it's like, what is the XC formulas? 1 by omega C. What is the XC formula? It's like omega L. So you're going to give the same formula here, and you're going to find an impedance value. With that impedance value, you're going to find your current. So this is what you're going to execute a program to find your current of your RLC circuit. And if you just first, now once you have typed your code, you're going to save this one. To save, again, you can use Control S or File Save As. I've used Control S now. I'll just show you like how to save here. We have something called save here. You can see at the above, new, open, save. So this save, you have to click it. You can save wherever you want. I want somewhere in the desktop, so I'm going to save there. I'm going to say as like sample test. Once I save that, you can see the sample test names will be changed here in the editor box. I'm going to run this one. While running, they'll be asking me to change the folder because I am not saving the MATLAB folder. I want to add this folder to the path, so I have to go for add to path. If I run, my figure window will open because I've used something called plot here. This plot command is used to plot my figure. You just see plot W with IW. W is nothing but your angular frequency. I'm going to plot my current with respect to the angular frequency. If I don't give W, what happens? It auto generates a time ratio, a time division, it auto generates, and you won't be having a particular value. You'll be having very small or irregular values, irregular figure will be having. So always, whenever you're plotting, generally plot with respect to the time or frequency, something like that. So this is what here. So I've used a plot, and I'm just getting my figure like this. So you can see already I've given my title. What's my title? Current with frequency. I'm getting a current with frequency here. What's my Y label is like current, and my X label is frequency. So everything I'm just giving here automatically generates the output. In detail about your coding, basics of your coding will be taught in tomorrow's class, in tomorrow's workshop. So I won't be much focusing on this codings right now, the basics of the codings. You just know what are the basic things. First, you're going to assign value, simple, give a variable name, say my name is Ramji, Ramji equal to something, some value you're giving, okay. Second, you're going to perform your task. For performing of task, what you're going to do, you're going to use certain formulas for that. So here I'm going to find for your XC and XL values. So I know the formula, my XC is nothing but your 1 by omega C and my XL is equal to omega L. So I'm going to specify that particular thing. So I know my impedance value, square root of R square plus XL minus XC the whole square. So I have the formula for that. So I specified that. Now I'm going to say my current is nothing but your V by impedance, V by R, V by Z, and then I'm going to plot that particular file. But if I want to see what's my impedance value, I can just simply click here. The same thing what you're giving there, IW, and you see what are the columns and vectors, everything will be here. And each column, what happens, everything will be specified here. And if you want to see the data, if you want to take this data, you can get it from your workspace. Here, you can get all the data, so your XC values, your XL values, your Z values, everything you can get from your workspace. If you want to like get it in your table form or something like that, I'll just show an example for that. Suppose I want for T. I double click this one. So I get my T value. I can save this in Excel or Word, wherever I want. I can save. I can use it for my future references. Okay. So that's very easy, something here. And if you do the same thing in the command window, what happens? Suppose I'm just doing the same thing in the command window. What happens? This I can save. I can use whenever I want. But this if I do in the command window and I press enter, it executes output. I get an output. But if I just do CLC, what happens? My completely gone. My code has been gone. Again, if I want to do the same code, again I have to type everything. So always when you're doing a complex problem, not a single line programs, kindly do in your M file. How to open M file? Is here. you open home, you have scripts. I've said to you again, I'm just reminding you, go to home, go to new script. If you click your new script, your tab will be open here. Okay, in this tab, you can just type your codes. So this is how your M file works. So this, I've given an example of basic RLC circuit. Okay, I've given your, I want to find a plot versus my current versus my frequency. So this is what the code I've written for. I've already defined my R, C, and L value. So RC value I'm going to define here. V is some voltage for your RMS circuit is nothing but 220√2. So that's what I've used here. And then I'm going to give the formulas for that, and I'm going to generate my results. So this is the output which I'm getting for your RLC circuit. Now your function block. Next comes a function block. What I said to you about a function block, it is something which is embedded in your Simulink file, which can be used for different input and different output variables. So here you want to specify that. Like for example, here your RLC value you have specified, but in case you're going to use for some other circuit and you don't have your specific RLC value, you're going to use for different systems, different times. So again, you should not go to the code, you have to not change in there regularly. You can just directly implement the same function block in your Simulink file where you're getting your RLC values, and you can embed the same thing there. So you're going to give your input, you'll be having your commands here in the function block, and then you'll be giving your output. So when you start here, there, I'm not starting with anything. I'm just declaring my variables. But what if I start from here in my function blocks? So my function block should start with, I have to use the word called function. What will be my output, which is equal to the function name and the inputs, what I'm going to give the inputs. In your earlier case, what will happen? My output was, what was my output here? My output was your Z value. Okay, and my input was RLC, 220 voltage. If you want, you can give, or you can use a simple voltage block. But okay, we'll see. Okay, RLC and V. These are my inputs. So my function will be like function IW, which is equal to your function name, any name which you want to give. RLC circuit you can give as name, and in inputs you can give like your R, C, L, V. So this is how you're going to specify your function block. Example I'm going to show here. Now I have designed a function for one certain task. Okay, my output for the task is something called DC, and my input for that is V and I. My function name is PSO. Okay, so this I have performed for one small task. Okay, and I've written all my code here. What is my DC? What is the formula for DC? How many iterations I'm going to use? What is my P? How to iterate P? How to iterate my V? Everything I've given here. You can see how to embed this one is something here. I have Simulink file. I'm going to, my V and I are completely variables. So I'm giving that particular V and I to my MATLAB function block. My MATLAB function block is this one. My function name is PSO. My output name is DC. This is where when your MATLAB function thing will be useful. About your basics of like this circuits will be explained in your last day, I guess, by some one more guest who is going to teach you with the power trunks thing. So we'll be teaching much about when you use a closed loop, because generally this function block is used for your closed loop control in a real-time system. When you want to do basic for PV, when you want to generate a duty cycle, or when you want to change the transfer function in control systems in the real time while your simulation is running, at that time you're going to use the function blocks. Now, something about your third step is your Simulink. I've taught you what is M file, I taught you what is a function block. Now, what is your Simulink? As I said to you earlier, Simulink is something but to like simulate or analyze a circuit diagram. You had a circuit diagram, you have done that circuit diagram in the RLC time, you have done that circuit diagram in way of code, using coding. But what if we can do it some other way? So I can use Simulink for that. This is generally used for analyzing your converters, your electrical circuits. For that, like your mesh nodal, your KVL, KCL values, your theorems, Thevenin's, Norton's, superposition theorem. But to verify that particular thing, so you're going to use your Simulink block. So it's very easy. Okay, you can even use a mathematical equations here. I like we have used that for Excel and XC. We have used in a term of code. Here you can use in a, again in simulation. You can give a mathematical equations in that particular simulation file, and you can run the same thing. The foremost thing which you want to know about simulation is simulation file is your simulation library. That's important thing which you have to know in this everything, because in simulation library you're going to use all toolbars. So you're going to use simulation library for that. Now I'll just explain you how to open a Simulink file. Like for the earlier time, for using your M file, you're going to use home new script. To open your Simulink, you have to go for something like open, new. This new you'll be having here something called Simulink model. If you just click this one, as page will open. I'll just show you what is that. So you can perform some circuits like this. We use too many applications. That's the problem happening. Yeah, okay. So now new box will be open, dialog box will open with something called Untitled with this symbol, which is your nothing but your Simulink symbol. Okay. You can see here you'll be having file. If you already have some simulation file, if you want to open, you can use file, open, something like that. Or if you want to have a new page, then you have to go for file, new, you can use a new model. In that you can create a one more new page for your simulation. Third comes to save your simulations, everything like that. So that's important thing. Next comes your simulation library, which I said which is very much important. So you can see a library browser here, something with the four squares, blue and red one. So this is your library browser. If you click that, usually first time it takes some time, because once you open a MATLAB, it takes all data what is there in your MATLAB and then it brings it, because we have lots of toolboxes here. But for as your students, your basic thing which you are going to use is simple power systems. So that's a block where you're going to find all your simulation thing. Actually, first time it takes some time, because you have to refresh all the thumbnails from your MATLAB software. But once you open one time, then next time will be very quick. So nothing to worry about that. So this is how your simulation library browser looks like. Okay, there are two ways you can search. If you know exactly where your blocks are placed, say I want to design a small circuit, okay, with like a small DC source is there. I have a load. I want to test something. If we know that, we can directly locate that particular thing, like your Simulink. Generally, we'll be having two ways. One is in sim power systems, and second you'll be having in your Simulink thing. Okay. So if you know that, it's okay. If you don't know, it's very, very easy. You can directly search here. Suppose I want a voltage source. You just click voltage here. I can enter. I don't know the exact name, then I can go with the voltage. If you know the exact name, you just directly click DC voltage source. As I said, the initial time will take some time because you have to refresh all the thumbnails and see number of toolboxes were there. So these are the whatever the name of voltage you'll get it here. Or what you want voltage source. So you have 2 types, but generally we'll be using sim power systems. Okay, you can just use a normal DC voltage source here. I'm going to design DC circuit, so I'll be using a DC voltage source here. I can just right click and add to Untitled. So Untitled is something but my name, my that particular simulation file name. This you can see when I've added here, I got my DC voltage source here. Okay. Now next, what I want resistance. I want some resistance or something like that. So for that, I can use the term which I'm going to use here is RLC. Okay. So RLC is nothing but you have your resistance, inductor, and capacitance in the same block. You can use it as resistance, you can use it as inductance, and your capacitance also. That is called a series RLC branch. So when we use this branch, you have something called load also. You can use that load, but generally load is only applicable when you're using high systems and only for the load purpose. But here, not only for load purpose, you're going to use for multi-purpose, so you're going to use branch for that. So I have my RLC branch. If I double click this one, I can either use as RLC, I can either use as RLC or combinations of your inductance, resistance, inductance, capacitance. Like this I can use. So initially I want resistance, I can use resistance. I can just give values. Suppose I want to use for 10 ohms. So I'm going to give it for 10 ohms. Similarly, my voltage. So I want the voltage for some 100, or I can just say 150 volt. My circuit for 50 volt. My circuit for 50 volt. Just give here. I just connect it here. Hello. Yes. Now I want to see what is my current and voltage of the system. So for that, you'll be using voltmeter and ammeter in your real systems. The same thing here. You'll be having something called voltage measurement and current measurement blocks. You just put measurement. Just put a measurement block. Whatever different types of measurement blocks you'll be having, it'll just show to you. You're going to use a current measurement block and your voltage measurement block. So these 2 blocks I'm going to use, and I got it here. So generally your you're going to connect your voltage measurement across your load, and your current should be in series, right? You connect your ammeter in series. So I'm going to connect in series. Now I got my voltage measurement and current measurement. Now how to see my output? There are 2 ways you can see your output. One, if you want in terms of numbers. Other one, if you want in terms of a graphical way or something like graph, what you say in the graph. Okay. So for seeing that, we have something called display. We use display block. So generally, I'm using water complex. I'm using under the tab of Simulink only, because that's a basic tab where we get all our basic things. In college level, first year, second year, third year, you want to use Simulink blocks only. When you go for the higher level, when you're doing some hi-fi project, something like that, then you go for your DSP blocks, your discrete blocks, and everything like that. Then I'm going to use display here, config here. This is to check my output in terms of values. Okay, the same thing. I can just simply right-click, control, and drag, so that I can get. I don't want to go back to library and again add to Untitled. So you can just simply hit control, right-click, and simply you can drag. If you get you can get a duplicate block. Okay. Suppose if I want to see my output in a graphical way, I can go with something called scope. Again, you have to just see the Simulink file. Under Simulink, you'll be having your scope. Now you got your scope. Again, I'm going to connect to my output here for my current, from my voltage too. Now suppose if I want to change the name, I don't want scope. For better way, I want to use this as current. I can just put current and in amps. Just if you double click that particular names, you can just change the names also. Can't keep same name for both, so I have to vary a little. So I'll keep a star. Can't keep same name for two blocks, so I have to just change a little bit. So I can just change. If I want to add, like I've used 50 volt here. If you want to see how much voltage you're keeping, you don't want to keep always open that and do it. You can just write that 50 volt here, so you can easily understand that. Suppose the resistance I've used like some time resistance I've used, I can just click here. I can use ohms. Now, foremost thing, once you have done your circuit thing, but still this will not give your output. Why? You need something called power guide. So power guide can say this is something like hard for your simulation. Whatever block you use, whatever circuits you use, you have to use power guide. We call it power GUI. Okay. Power for your graphical user interface. So Simulink something about your graphical user interface, you're going to give it a power to it. Okay, just a small block it is, something like this. Power GUI. Okay. So for normal circuit analysis, for normal converters, you're going to use continuous block. We are not going to change much of your system. But once you use your discrete systems where your input are continuously varying second to second, milliseconds is just changing, there you have to go with your discrete model. You just go to configure parameters, you can change to discrete. Okay. So these are the two main parameters which we electrical engineer will be using. One is continuous, and other one is your discrete parameters. So I just want to be in continuous because my system is very simple systems. I'm not using any complex systems here. And if I run, so next comes your runtime actually. So how much seconds do you want your simulation to run? Seconds doesn't mean your exact time value, but your simulation time. Your simulation time will be either large or you can just keep it for small. It's very simple. I can say that my complete circuit will settle within milliseconds. So I can use just 0.1 second also. I'll just show the variable what happens when I use more time or less time. Just change the time. The simulation started running. You can see here, first initially it compiles, it just find out for some errors in that. So after compiling, it gives you the results. So my compiling is almost done. And I got my output. So I'm getting a 50 volt because I'm getting a 50 volt as this thing. And I'm getting my current as 5. In DC circuit, your I is something about V by R. So it's like 50 by 10, you're getting as 5. So this is how your basic simulation is done. Okay. What if I'm going to change it? And I'll just show you the scope thing. Same thing, what you have gone in the value wise, you're going to get it here in your graphical way. Graph. We have an X label, Y label, and your output 5 ohm. Okay. And like generally when you click, you have to use auto scale here to get exact thing here, because if you just see before, it was like from 0 to 5. I was not able to see my 5 because it was in line with your axis. That's why I've done auto scale. The auto scales itself and give the perfect values. Okay. So it's very easy for us to see. I can see I don't have any settling time because I'm just getting my divert output. So I've used very less time from 0 to 0.1 seconds. What if I'm going to use some 100 seconds? What happens when I use 100 seconds? Doesn't matter much. My simulation time will increase. That's it. And I'll be getting the same output. Same thing I'll be getting. See, I'm not able to VC my output. I have to do auto scale here so that I can get 250 volt. From 0 to 100 will show my output. Only my time axis will change from 0 to instead of 0.1 to 0 to 100. That's it. Okay. When you're using other very complex systems where you have more settling time, at that time you have to take care of your simulations. When you're using a basic normal circuit, it's advisable to keep for 0.5 or 1 second. It's more than sufficient. Because unless your simulation time will increase. So this is about a basic circuit. Now let's perform some circuit analysis. Okay, so let's see the first one. Here we have KCL. So what does KCL means? It's a current law. At any junction, the sum of incoming current is equal to sum of outgoing currents. Okay, so let's modify this, or I can just open a new one. File, new model. I'm going to use a new model now. It's entirely for your KCL. I'm going to save this first. I'm going to empty itself. I'm going to save this one. Save as. Save it to desktop. I'm going to give it any name. So I'm giving a KCL. Name as KCL. Let's save. Automatically the name will be changed to KCL. See here. Now again I'll open my library. Okay. So first initial thing I'll just take my Power GUI, because I heard if you don't use Power GUI, you'll get an error. Whatever your circuit is right, you get an error. So first I think I will use Power GUI. Then next I'm going to use some DC voltage source. So I know the name, so I've given that DC voltage source. In case you don't know that, you can use voltage and you can search. Okay. Or you can, if you know exactly where it is located, you can see it's a very huge toolbox. It is there. You know exactly where it is located. You can directly go that particular place and else you can locate. It's better. It's advisable to search actually. Searching is very easy. Next, what else I want? I want an resistance. So I want to go for RLC branch. I just RLC. I'm going to use series RLC branch here. Okay. For my measurement of my current, I need my current measurement. I know the name, so I'm giving you that current measurement. If you don't know, you can just give directly as measurement. If I just enter, you can get your measurement block. Yeah. Now we'll just perform a small KCL. So I have one input source here. Powder here. Again, right click, control, simply drag. So you can see here it is in horizontal way. If you want in vertical way, you can just simply rotate this one. For rotating, either you can use right click rotate option, or simple thing is control R. Control, or you can just simply go for control, and you can see you can have a rotate thing here and go for anti-clockwise or clockwise. Either you can use this one, or you can just simply put control R. I'm using control R right now. You can just control. I've done this one. So I need one more resistance. I will just keep it here. I'm going to keep the current block here. My current here across each. So I can simply like click and drag the connection is there. It's very easy. Connection is very easy. Simply click here. You can get this positive symbol. Click, right click that, drag it to your component and just leave. Okay. So you can just connect entire block like this. change it to resistance. I'll do some resistance like 10 ohms. Some 20 ohms. And this one. Some 15 ohms. It is 100 volt itself. It is 100 volt. It will be 100 volt itself. I can just change it to 60 volt. Whenever you can change. To view my outputs, I need two blocks, either it's scope or display. Since it's just a value, I'm not going to use for any graph way. I can just simply use my display block here. I'm going to add it here. Okay, now I'm going to run this one. So you can see, okay, the thing which I've done here is I've just interchanged my current measurement block here. You have to rotate this to anti-clockwise, but I've done the clockwise. Means that my current is flowing opposite direction, so it's showing the negative. If we just add this both, let assume this has to be positive. I'll just change this block. Then current flows from here to here, right? Now I see. If you just this is your incoming current at this node, so it's 3.3, and your current is leaving to these two directions, 1.3 and 1.8. If you add both, algebraic sum will be 0. Okay, sum of incoming current is equal to sum of the outgoing current. This is how you verify a small KCL, Kirchhoff's current law. Same thing you can perform using your Kirchhoff's voltage law, but so Kirchhoff's voltage was also same thing. You can use the same. You can use the same block. Okay. So instead of that, I can just simply I'll use a new voltage measurement block.
मैं तो इसके ऊपर आ गया ना। हट जाओ।
So I want 3 voltage measurement blocks, but use the same thing. You can use the same circuit diagram, or I can just, if you want some other circuit diagram to perform, you can use the same thing. And you have to just current your voltage measurement across your components. Okay, just use the display for that. On this one, if you see, my input is 60, and if you add 2 resistance, that is your this one and this one, you'll be having 60, because this is is being divided by your resistance and resistance. Either you can remove this one, or I can just keep. This is usually fine when you use your voltage divider rule and all that. And that during that time you can use this kind of circuits. If you want to just see your Kirchhoff's voltage law, algebraic sum of your voltage at any node is 0. For that reason, if you just see, so at any node, let's say I'm going to use any node, and during that time, what happens? I have 32.31 and 27.69. If you just add both, you'll be getting your 60 voltage output. Okay. Now, if you just see, the system is completely congested. It's like overlapped here and everything like that. What if I don't want to use this measurement blocks? I don't want to use this measurement blocks. I just want everything in a single graph or single value. I just want, and I don't want to like have this much clumsiness. For that, you can use something called multimeters. I'll show you about that. I'll go for the new model. Again, I'll use the same components what we are using for now. I don't want to use any measurement blocks, but still I want to see my output. For that, use a DC voltage source. I'll use my series RLC branch. That's it. And your power GUI.
Excuse me, sir. Ramji, sir.
Sir?
Sir, can you explain slowly, sir? Some beginners are here, so they are feeling somewhat fast, and some disturbance is coming from your backside, sir. So try to avoid that, sir.
Okay. Okay.
Please. Okay, sir. Can you explain slowly, sir? Thank you, sir.
Okay. Right. So again, let's say I want to start a new one. I'll go with slowly this time. Okay, I'll just simply remove this everything. So initially, I've taught you how to open a new simulation file. Now we go for, in home tab, we'll be having something called new scripts, new open. Open is when you already have a circuit thing and you want to open that, then you're going to use open for that. But when you open a new one, first time you're going to do some circuit thing. At that time, you have to go for new Simulink model. So if I click that, I'll be getting a dialog box like this with some name like Untitled 1, 2, because I already have Untitled, so it's like Untitled 2. I'll be getting something like this. Okay. So here you'll be having something like simulation browser. Your library browser will be there, which is nothing but your 4 squares will be here, red and blue color. This is your library browser. Just click this one. Your library browser will open. Here, when you know exactly where your components are placed, generally our components maximum placed in sim power systems. Here you can see sim power systems, and we're using maximum components here. So in the connection port, everything will be here in sim power systems. Simscape components, the connections. If you're using any machine parameters, your machine parameters, all the machine parameters will be there. Passive devices, and everything. Semiconductor cycle switches, MOSFET, your IGBT switches, your sensors, your sources, everything you can find in your sim power systems. Okay. Let's say you don't remember exactly where sim power systems are. You'll find difficult to locate your sim power systems. During that time, what you have to do, you can just simply search. I want a source. I want a DC source. Either I can search as DC voltage source, or simply I want a voltage source. I'll just click as voltage. So whatever toolbox with the name of voltage will be shown in that particular file. Okay. So whatever the voltage name is there, I can find it here. I want a DC voltage source. For my DC circuits, I want a DC voltage source, which is here. Okay. You can just simply right click there. I can say add to Untitled 2. So that's what I've opened right now. Okay. So the last tab which you open and show us add to Untitled 1 or 2. The last which you open, and that one it will show. Okay. Lastly, I've opened Untitled 2 only, so it will show like that. I just right click, and if I say add to Untitled 2, then I can see my DC voltage sources here. Okay. Next, what do I need for a circuit? I need some resistance. For that resistance, you can, if you just search directly as a resistor, you won't get that because you'll be getting in some other platform. Okay, so it's better to use an RLC series RLC branch to be there. You can simply search as RLC. We're having a series RLC thing here. So you can use, there will be two types, like you'll be having series and parallel. So parallel we're not going to use it right now because we don't need it for exactly for power system space thing. We'll be using a parallel RLC blocks. Okay. Let's go for the series thing. So series will be having two things: series RLC branch, series RLC load. When you want to specifically use only for the load, then you can go with your series RLC load. But no, we are not going to use specifically for the load. We're going to use the resistance common for your source as well as source. So you're going for your series RLC branch. Right click, add to untitled. Okay, so this is done. Third thing, what we have to do, as I said, your power GUI. Your power GUI is nothing but hard for your simulation file. So I'll just put as power GUI. Enter. We're having a power GUI. Only one block will be there. Simply click add to untitled. We have this thing. It's done. Okay. So I'm going. If I want to again get one more components, I don't want to go to library. Again, I don't want to search. Simply control, right click, and simply drag. So you'll be having multiple times you want, you can use same component. Okay. So this thing I'm showing how to use a multimeter actually. Instead of using that voltage measurement, instead of using the scope, multiple scopes, multiple measurement thing, I'm going to use your multimeters this time. Okay. Simply, if I want resistance, I'll use this resistance. I'll give some values, whatever values I need, say 20 ohms I need. For this measurement, now this measurement box to be used. To click this one measurement box, you'll be having three things: branch voltage, branch current. If you want branch voltage and current to be measured. If you want only voltage to be measured, like you have seen only in KCL, you'll be using only your current measurement. Whereas in your cable, only you'll be using your voltage measurement. So based on that, you can choose. No, I want to measure both my voltage and current. So you can use branch voltage and branch current. Okay. Apply. So now I need one more circuit. I can just simply name this as my resistance 1. Okay. Control R to rotate, or right click, rotate, flip will be there. You can rotate clockwise and anti-clockwise. You can use either way. Okay. So Control R is the shortcut. Control R. Again, double click this one. You can use only resistance. You can change these parameters to whatever you want. I'm going to use some 20, or I can say I can use 40. Again, measurements. I want both voltage and current, or I want just voltage. You can choose, but I want only voltage. I choose only as branch voltage. Apply. Okay. So one more resistance I have, and I'll do the same thing there. Resistance, some 33 ohm, and I'm going to use only the current for this one. I'll put current. Apply. Okay. So on this, connect this box. So now this one is I'm going to use something called multimeters. Instead of using multiple voltage and current measurement for each and everything, one block is enough, because I'm going to use measurements in each and every component. Something called multimeters. Let's put multimeter here, enter. Having only one block, add. So we're having multimeter here. Now, just double click your multimeter. It just, we have given you measurements for each and every components. Refresh that and you can just see. So your resistance 3, we have taken your voltage. For your resistance 1, we have taken voltage, and as well as your current. For resistance 2, only we have taken current. So complete this will be here. So what you have to do, Suppose I want only right, I just want resistance from voltage and resistance from current and resistance 3 voltage here, and I will just click this arrow here. I click, so this will be selected here for measurements. I don't want to see now my resistance to current. I don't bother about it. So I can just click only what else I need. I can just click it here. So it will be used for selected measurement will come here. Okay. I can just change the like let's say format that in which format I want. I want both voltage and current first, or I just want my resistance 3 should be at the last. I can just change that to last. It will be my resistance 1 and 2 will be in first position, second position, and third position will be resistance 3. I can just put, and I can just say update. Okay, so automatically once you click here, you can see you have chosen 3 measurements here. Okay, it is showing us 3 measurements here, and I'll just close this one. Now what happens? We have 3 measurements in this plot. Now I want to make this 3 resistance to be 3 values to be individual thing. For that you have to use something called Demux. You have here something like mux and Demux. Mux is many to 1, Demux is like 1 to many. So you have something called Demux here. Demux and enter. Simulink to untitled use. We just use something Demux thing here. Correct. But you can see only 2 will be their output. Initially that will be a predefined one. Okay, we have to change. Now we have 3 outputs, so you're going to change it for number of 3 outputs as 3. I'm going to say apply. Okay. Now we got 3 outputs. You can see. Now I want to see this one. Either I can use scope or I can use display, which I've said you. So I'm going to use scope. If you want to see all the 3 things in a single scope, even that you can either you can use I will click this one. Go to the scope will be having something called set parameters. Click the parameters. Number of axes will be there. Now we have 3. You can change this to 3. Click apply. You can see your single scope window has been changed to 3 different output windows. You can press the close. I can just bring this out. Now you can see your scope is having 3 different input variables as that. So you can just simply connect. And I just done. Time doesn't matter for me because it's just a simple circuit. So it will run whether I keep my 0.1 or 1000 doesn't matter. It will run very quickly. You can see. I have to do auto scale here as you said because then only your output will be visible. You can see all my voltage and current here in my plots. This is how you, instead of making your entire circuit complex like what we have seen in the previous time. Just see here. It's totally complex. You are not able to visible what is here, what is here. It's totally complex and it's very tough to, difficult to understand. So for that thing, you're going to use your multimeters like this. It's very much clear. Like you won't be having much complexity in your circuits. Everything will be having the bottom of the circuits easy. Suppose now I want to see my resistance, my to current also. Even that I have to add here. So I have to click here again. I have to just use this add button. I'm going to add it here in the 4th. Okay. But I want to make this as my 3rd output. I can move up. I can see it's like resistance 1, voltage current, resistance 2, current, and resistance 3 voltage is there right now. I can just simply update and close. Instead of 3, now here 4 will be there. Okay. Now, double click this one. Again, we have to change this because earlier we were using 3 inputs. So we are using number of outputs is 3. Now we have 4. We have to use number as 4. Apply. Okay. So automatically, your one more variable is being output variable is increased here. Even in the scope, you can just double click, go to your parameters, and simply click axis as 4, apply. And just see 4 parameters have been generated now, and current is 4th parameter here, and you run. auto scale. So whenever you run once, you just do auto scale. That's important, very much important. Then you get perfect thing. I can see you having your 4 output this thing. So this is the way how you see your output, basics of your Simulink and everything. Okay. So you have known how to use the multimeters, where scope is used, why display is used. To remove that particular complexity in the circuits, you can use multimeters for that. You can use a measurement block which is present in a component thing. So everything is like visible to you. Now next, I'll tell you something about your theorems. I want to verify some theorems. Theorems are again a bit complex, and you'll be using multiple things. Let's say when finding your RTH, in calculations you'll be having your R1 into R2 by R1 plus R2. But here you can't find that, so you'll be having a formula for finding your RTH. I think, but your R is nothing but your V by I. So you'll use some mathematical function blocks there. So how to use that? What is the term's name and everything? I'll just tell you in the coming slides. So KVL we have seen. We have seen KVL. We have seen multimeter. How to use a multimeters here. Next is your superposition theorem. So superposition theorem, again, if you want to verify, we'll just verify that also now. Again, we'll go for file, new, model. So what is superposition theorem? The current across any component. We're going to use two sources here, right? In superposition theorem, we'll be having two sources. So we're going to use two sources and keep it like this. Next, we're going to use your resistance. Like if you already have your old Simulink file open, you can just simply copy paste also. That will be very easy for you. Control C and Control V. Same what we use for a word. Control C here. And just Control V there. Instead of going library again and again. Control V here. You can simply copy paste. Again, I can copy. Say, just paste multiple times. Whatever how many times I need, I can just paste that using Control V. Already we have used measurement, so it will follow the same pattern what we have done there. Once we have used measurement, I think that values, whatever we have given there, when you copy paste, it will follow the same pattern, same value and same configuration what we have used there. So if you want to change, you have to change it here. So I'll just keep that as 20. I'll keep this as some like 40. This as 60. In one parameter let it be 100, another parameter let it be some. One more thing, which I said you power GUI. I'll just show you what happens when you don't use power GUI. A diagram emitter is shown. It's showing like something your command is not being initialized because I've not used my power GUI. For that reason, when you get like something like this, then you remember that you are going to use power GUI. Generally, what happens when we perform certain circuits, we won't be remember to add that. So whenever you get something like this, don't scratch your head for searching some faults in your circuits. It's just because you have not used your power GUI. So whenever you do, first you add power GUI, then you perform your circuits in Simulink. Power GUI, then just do like that. Now I want multimeter. Next I need display. Just go with the display. So automatically already we have given your both voltage and current measurement for your each resistance, but we are going to just see the current. So we just copy our 3 currents here, just keep it here, update. Let's just go at Demux. We have 3 outputs, so I'll just keep this 3. So minimize this one. Display we can't go with the multiple thing, so we have to use individual display for that. For scope we can have in single file and not in display. So this is the current which you're getting. So if you want to check for a superposition theorem across my resistance R5, what you have to do? First, you have to short circuit your 1 voltage source. Then you have to short circuit your other voltage source. If you just compare, add the both currents, you will get your like if you add both currents, you will get your total value. So R5 is.
I have a doubt for you.
Yeah, tell me. Someone was having some doubt. Can text me once they have doubt. Certain queries is there. So once I complete the superposition theorem, I'll go with your queries. Okay. So I'll just complete my superposition theorem first. So we can perform everything in a single window itself, no need to open again and again. Friend, I've just here. Simply I'll select all. I'll just put Control C and Control V. I'll just copy paste. Now I'll short circuit one of my source. I'll short circuit this one, and I'll just simply drag. So once you're doing this one, make sure remember to update your multimeter thing. Since we're using multimeter, we have to update that. Okay. Now you'll be having more. So why to make so much complex? We'll simply go with your display and current measurement. So that will be easy for you. But if you're using multimeter, you have to keep on update your multimeters. Earlier we were having only 3 resistors, now we have 6 resistors. So you'll be having 6 voltage and 6 currents. So I can see superposition theorem. First, we have initially 2 voltage source. We want to measure current across resistance R5. Okay, across this resistance. And next time, what you do? Once we short circuit one of your source, and second circuit will short circuit other source. If We just run. Let's see what happens. You can see your total current here is 1.136 across your resistance R5, this middle resistance. Okay. So due to the source 1, we have the current as 0.90. Due to the current source 2, you have 0.22. And if you add 0.90 and 0.22, you will get your 1.36. For that, you have to use, if you don't want to do calculator, if you don't have calculator right in a hand, you can simply use some add block or sum block. Can use anything, add or sum. Okay, we have add here right now. So I'm just simply I'll just add this both. Use one more display block here. Next one. So you can see 1.136. Okay. So like this, you can say your superposition theorem has been verified. Similarly, you can do for your Demux theorem also. Generally in Demux theorem, what you do, you short circuit your load resistance, then you find your VTH, your RTH, and everything like that. So here, what we can't go with your R1, R2. Again, you're going to instead of doing panel calculations, what you do at the place of your load resistance, you're going to place your a small value of DC voltage source to get some current. I'll show you that also. Other way to open new one is Control N. If you use Control N, new Simulink page will open. Okay. Again, we'll go with a small DC voltage source. Then series RLC branch. Then our GUI. I go with simple circuit rather than going for a complex one. So now let's consider this as our load resistance. Okay. Now we have to find our tenants. We have to simplify this thing into a just one single source, single resistance thing. For that, what you have to do, you have to first to find your RTH. What we do, we eliminate your source, we short circuit your source, and then we find your RTH. Okay, this is what we do. So going for band calculation, what we do, we remove completely this one as we short circuit or this thing. So instead of this, what we're going to do, we're going to add a small source. So what is this? We'll add a small source of 1 volt. Because if you don't give any source, what happens here in Matlab, your system will not give any output. For that, you have to add small source of 1 volt. Okay. Now you're going to find your current across this point. This is the current measurement you're going to use. What do you use it? So voltage across your load resistance. Your resistance in series, sorry, your current in series circuit, your resistance. So next, you're going to use your display. Then displays, one for your current, other one for your voltage. Now, for your DC circuit, your R is something about V by I. Okay, so you have your V, you have your I. So to find your R, you have to use something called divide mathematical function problem. So this divide you can use. Simply V have current to this product sign, and which is divided by I. So this block is nothing but your RTH block. So only thing which you're going to do is going to add 1 volt DC voltage source. Because if you don't add, what happens? No voltage source, no source is there in the simulation, so it doesn't run. To make your simulation run, you're going to use this one. This is how your again I've wrongly converted this one. I've converted beta, so it's a negative. And vice versa, you can connect and you can get your RTH. If I don't use DC voltage source, what happens? You won't get any output. So to remove only this thing, rather than your normal circuit diagram, what you use, you have to add this one voltage. See, now short circuit limitation because you're not using any kind of sources here. No, like you don't have any connection between your series Rlc Circuit in series Rlc as well as in parallel. So that's why it's showing as an error here. So for that reason, you have to use a DC voltage source. I'll be sharing you to try by yourself. Okay, take a small circuit. You try by yourself. Okay, and if you have any doubts, my mail ID is there in the PPT. You can text me. Okay, I'll mail you a basic Thevenin's theorem, Norton's theorem, superposition theorem, nodal analysis, mesh analysis, your KCL, KVL, basic circuit diagrams I will give to you. Try by yourself once so that you'll get a clear idea. But just by seeing, you won't know anything. You must have a hands-on training in that. This is what for bigger circuits I have done this Thevenin's theorem. This circuit diagram I'll just send you. And you can just try manually. You can verify with your simulation thing. If you just see, simulation will be quite easy actually, rather than doing manually everything. So, thank you for the opportunity given. Now I'll clear your queries. I guess I've taken a long time. Which MATLAB version is useful for researchers and what is update version? So currently 2020 is updated one, but for researcher depend upon what kind of models you are using. Suppose you are using a very basic model, 14 is more than enough. I'm using 14 right now. In this, I've done my PhD in wind energy. I've done some control strategies also. I've used some AM strategies also. So 14 was sufficient for me. But if you want to do much more advanced in PV, like you want to go for partial shadings and something like that, advanced version, then above 18 is fine. Yeah, I'll be sending, through your organizer, I'll be sending the basic simulation thing which I have.
Ramji sir, we have one more question. That is, what is difference between scope and display?
Yeah, okay. For those scope and display, when I've just shown you right now, again I'll tell you, scope is to get anything. Scope is anything which you want to get in graphical way, like your graph you have, your x-axis, your y-axis, and your output. Okay, but your display is just direct value. See, you can't get in a graphical way. It's just 1.136. But I want this in graphical way with x-axis and y-axis. Then I'll be going with your scope. And if I just run this one, same 1.136 will I'll be getting in the graphical way, like with the x-axis and y-axis. Here. So auto scale here, you can see 1.136 output, 0 to time. The time which I've given, I've run for 0 to 10 seconds, so it's 0 to 10 here, and this is my y-axis. So I'll be getting in the graphical way, same thing. Because when I'm using a constant values, constant output I'm getting, so display is far better than rather than always opening my scope. But when you're using some non-linear output variables, at that time scope is suggested. Okay. So depend upon like how your output variables are, you can use either scope or display.
So, excuse me, sir, Ramji sir. Here we have one question. What is the difference between display and scope?
Just no, sir.
Yeah, it's completed. Ramji sir, we will take one more question.
Yes,
Hemant Sundar, he's asking like, we need multiple displays to display multiple values instead of. Is it there any way to display multiple values in a single display?
No, sir. No, we don't have for this thing. Only for scope we have that one. Not possible. Not possible.
Yes. THD will okay. This will be in further sessions.
Further sessions, sir. THD.
Sir, one more question, sir.
Yeah.
In Power GUI, difference of continuous and discrete, sir. Difference between.
Yeah. Discrete value when you have like simply for example, I tell you PV, when you're designing some PV system, okay, you'll be using a non-linear input variables. Like PV is completely dependent upon your irradiance and temperature. That is completely non-linear in nature, or you can say discrete in nature. In that time, we need discrete thing because to specify each and every pinpoint of that. But for normal circuit analysis, we use power continuous. Notice that we don't want to change much in your input variable. The DC voltage source which I've given 60 volt. It's 60 volt throughout this my simulation running time. When it's 100 volts, 100 volts over the running simulation time. I'm not going to change anything in my input variables during that time. So I'm using continuous for that. If I use,
sir,
one
more question, sir. How will get variable names on graphs, sir? Graph sheets, sir?
A variable name on the graph sheet. There are two ways actually. I'll be telling you one way, which is not that much tough. One way you can use your scope. In scope, you can just go for double click your scope. In this parameter settings, you can go. In history, you can go. I can just change here. The second one, which I'm going to tell you, is quite easy. Okay. You can go with two workspace. I said you whatever valuable you say, you save in two workspace. There are two ways to get your output in two workspace. One is using two workspace model. Okay, I've added here. Let's say I'm just going to connect it here to my output. I'm going to change this as some current. So I'll just change this my name as current. Anything, any value I can just change. Okay, I'm going to run this again. So once the simulation is done, my workspace in the first page of my MATLAB here. Okay. So here, if I go, I'll be having the name called current here. Here, current. You can see this current here. You can right click. You can go for plot. Once you plot this one, you get all data here. Go for edit. Go with figure properties. Here you can change this one. Double click this data, you can change this current amps. You can change this to time or something. What else variable you're using, that one you can just change. Change it here. Then actually, it's going to change something, some other thing like that. I'm just going to use so time. I'm going to use as a frequency. You can change it here. Here you can just get your all labels of your x-axis and y-axis. Here one more advantage is that when you want to use for some other purpose like for presentation or something like that, you can if you just take from scope, what happens, your line width will be very less, you won't be having that much clarity. But here you can go with multiple, you can just increase the width of your lines also, and you just go for 4 and see the width, and just change the color also to red. You can just change the font also. If you just go to the font, you can just change to whatever fonts you want, how much size you want. Here you can just change. Like this you can just change. And I can just save this one to JPEG or whatever format you want. I'll save as. I'm just going to save this to some file name called sample. JPEG format. Save. So that will be saved in my desktop. Yeah. So that figure you can just save here. Be having your access in y-axis. By mistake, my y-axis is going to be deleted. You just do slowly, you can just get that name also. Any more doubts?
Yes, sir. So why we have to use only Demux?
So actually, we have multiple variables now. You have to. Then Demux is a basic block. You use a mux if you have to combine many. Even like what to say, why only Demux is like it's a basic block actually. You don't have any other block for that. One variable to many variables, you're going to use Demux. Multimeter will be having multiple outputs. What based on your thing, be having 3, 4, 5, 6, whatever you get. So that is single variable actually. Once you want to separate that, you can get it. If you don't use Demux, what happens? I'll just show you that also. If you don't use Demux, what happens? Everything output will be in a single graph. And single graph will be like when you go for comparison, then it's okay. I'll just show you an example of Demux. Okay. So if I don't use Demux, what happens? I'll just show you. If I don't use Demux, I'll be having only one output here. All 4 figures are embedded in this one only. I'm going to run this one. You open this, you can see all 4 outputs are visible here. 2 will be very current, so it's less. Your magenta color, your blue color, your yellow color, your red color. So all 4 outputs will be here. To make this output separate thing, you're going to use Demux. We have one Demux as a variable. I don't remember any other variables we have. Any other tuples we have. So when you're using some comparison, then you can use mux and you can compare 2 currents together. Across 2 resistance or 2 voltage across 2 resistance. When you compare, then you can use mux for that. But once you're limiting that to multiple output variables to single output variables, then you have to use mux. That's the difference.
Sir, one more question, sir. Why is ground is not necessary in the circuit?
Not required here. Not required in circuits. You can use that. That won't give you any other different answers. It's the same. Just for a protected device. When you are using some solver functions, at that time we'll be using ground. Okay, where your one loop will be open. Suppose you are using some circuits where your one loop is open, other loop is closed. At that time, you will be using ground. But everything is closed, so ground is not required.
Sir, one more question, sir. Can we get analog signal in scope, sir?
Analog signals you can get your analog signals also. I guess in upcoming sections, tomorrow or day after tomorrow, we have some power systems that will be telling you how to get a different thing in your scope, different signals in your scope.
So some of the students are asking that reference books are available, sir. Any reference?
Reference book is there. Yeah, reference book I'll be sending you. We have one reference book. Okay. For your basic circuit, we have another one. For your next year powertronics thing, we'll be having different one. So I have two reference book which I'll be sharing with your organizers.
Okay, sir. Thank you, sir. So Kumar, sir.
Hello.
Hello.
Yeah, ma'am, I'll take up this end of the session.
Yes, sir.
Yeah. Good evening to everyone, all the participants. Hope you enjoyed the session. So myself, Sudhir, head of the department, SV College of Engineering. So coming to today's session, we mainly focused on the Simulink and its application in electrical circuits only. So actually, for discussing this particular area itself, it might take 2 to 3 days. So, but Ramji sir, he just explained in a such a manner, like he covered everything, whatever the basics you require, everything sir has covered. So Ramji sir, thank you so much for that properly organizing your session, and I want to wish you one more once again, happy birthday to you on this special occasion.
Thank you so much.
We want to continue the same thing because I know you very well about your research stuff and whatever be your stamina, because you are the one of the best in select school VIT, best researcher during your session. Thank you so much for your valuable knowledge sharing to our student participants, and you providing your valuable time for our SV College of Engineering. Thank you so much, Ramji sir.
Thank you, sir. Thank you so much.
Thank you so much.
Thanks for providing the opportunity, sir.
Yeah, sure. Hope you remember me, Ramji sir.
Yes, sir. Sure, sir. Yes, sir.
Yeah. You're also one of my good friend, like Charan and Saravanan. I will continue the same in future also.
Thanks.
Yeah, thank you, Ramji sir. Participants, don't worry about everything. So it is actually it's not a rushing session. I want to convey one thing. So Ramji sir has spent in a proper manner to cover all the things in given 1 hour time. Okay. So sir is going to share whatever the material he used with us. So once we receive that particular material, we will be sharing the same via your mail. Okay. Please don't forget to fill up the feedback form. So it's mandatory for receiving the certificate for all the 5 days. Please go through the recordings, whatever maybe we are going to sending by today night itself. Practice more, so that see, I'm sure that after attending this 5 days session, so you'll be able to do your mini projects using the MATLAB. So whatever you require, please ask to the resource person. We will provide the same. Ramji sir, thank you so much for being with us on behalf of our SV College of Engineering Management, as well as my team, Kumar sir and Sunita ma'am. Thank you so much, Ramji sir.
Thank you, sir. Thank you so much. Thank you all for the wishes. Thank you.